Today we're going to learn about a part of thermochemistry called specific heat. The definition of heat is the energy that transfers from one object to another because of a temperature difference between the objects. When we do calculations with heat, we use joules or calories for heat. One of the effects of adding heat to an object is an increase in its temperature. So the demo that we did yesterday with the wire mesh and the Bunsen burner, we held the wire mesh in the Bunsen burner flame and we saw the heat transfer from the flame to the wire mesh. Heat will always flow spontaneously from a warmer object to a cooler object. So in that example, the Bunsen burner flame is obviously warmer, and that heat spontaneously transferred to the cooler object, which was the wire mesh. If we held the wire mesh in the Bunsen burner flame for an extended time, we would see that the temperature of the mesh would eventually equal the temperature of the flame. This is called thermal equilibrium. The definition of heat capacity is the amount of heat needed to increase the temperature of an object by exactly 1 degree Celsius. Heat capacity of any substance depends on that substance's mass as well as the chemical composition. For example, if I have an iron nail versus an iron bar, the iron bar is going to have a greater heat capacity than the nail, because an iron bar weighs more than an iron nail. Different substances can also have the same mass, but they may have different heat capacities. So if I had a block of copper versus a block of nickel, the blocks could weigh the same, but they'll have different heat capacities because they have different chemical compositions. Specific heat is the amount of heat that's needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. When we do specific heat calculations, we use the letter C to represent specific heat. If you look at the table below, we have a list of different substances and their corresponding specific heats. So we can see that 1 gram of aluminum has a different specific heat versus 1 gram of copper. We can calculate the specific heat of a substance by using the formula C equals Q divided by M times delta T. Let's look at what these variables are. Q is heat, M is mass, delta T is the change in temperature. So to find the change in temperature, we take the final temperature of the substance and subtract the initial temperature from it. And that will give us our change in temperature. And then C is specific heat. Let's work through a specific heat example. We have our equation C equals Q divided by mass times delta T. The example problem states the temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 degrees Celsius when the copper absorbs 849 joules of heat. Calculate the specific heat of copper. So our very first step is to identify the knowns that are given to us in the problem. So let's look at Q first. Q is the heat. We're told in the problem that copper absorbs 849 joules of heat. So Q is 849 joules. Mass is also given to us in the problem. It states that there's a 95.4 gram piece of copper. So for mass, I can put 95.4 grams. The final temperature which is T final, it states that the piece of copper, the temperature increases from 25 degrees to 48. So since it's going to 48, I know that that is my final temperature. So I can put that as my final temperature. The initial temperature is given to us in the problem. It's 25 degrees Celsius. To find the difference, I take my final temperature, subtract initial, and then this is my delta T, or change in temperature. Step 2 for solving for specific heat, we plug in the variables into the equation and solve. So we're looking for specific heat, which is C. We plugged in heat, which was 849 joules, divided by 95.4 grams times our change in temperature, which is 23 degrees Celsius. So this is Q, this is M, and this is delta T. So once we've plugged in all the values, we can go ahead and go through the order of operations and solve. So very first thing I'm going to do is multiply this 95.4 grams times 23 degrees C. After I've multiplied this, I end up with 2,194.2 grams degrees Celsius. So now I can do the division. So 849 divided by 2,194.2. After I divide, I end up with a specific heat equal to 0.387 joules per gram degrees Celsius. And we're done.